Last year, I made a video about my crappy little SDK project for the original PlayStation called PSn00bSDK. Whilst it was somewhat limited in a number of important areas at the time, it was certainly more capable at GPU and GTE stuff that frankly no other open source PlayStation SDK project that I know of has ever really come close in such areas, especially on the programming side. And as with any project that has received continued development, a good portion of which done by me, PSn00bSDK has certainly improved a lot since we last saw it on this channel. Here's an insight of what has changed, how the significant additions it received were developed, along with a custom cheat cartridge firmware that I've developed to complement the whole package. Hello, this is Lameputer and wait a minute, something isn't right here. What could it be? Oh yeah, the framing is like that of a fucking internet Nancy boy, and I'm no Nancy boy, so, well, let me fix that. A bit annoying that the zoom control on remote is a bit slow here. Maybe one more moment. Alright, there we go, much better. And ooh, my hair is quite long now. I guess it's due for a haircut some point, maybe next year. So, alright. Basically, I'm just gonna ramble on about what has changed in PSn00bSDK since I did that video of it last year. Assuming I can get this video done before this shithole of a made in China flu year comes to a close. And I'm also gonna ramble on about another thing that you should know what it is since it's in the damn title of this video. And that's really about it. And if you came here expecting me to do like a tutorial video on how to set up PSn00bSDK, well, sorry to burst your bubble, I'm still not inclined to do those. However, I have a much better solution that I'm gonna ramble on about in the post-ramble of this video. So stay tuned for that if you're still interested. So anyway, I guess that's about it for this pre-ramble thing. So I'll get on with it. Now where do I begin on this one? I don't really know exactly, as this project is pretty fucking huge, easily among the largest projects I've ever created, and is only going to get bigger as long as this goes on. Whilst PSn00bSDK's library documentation isn't complete yet, it is at the very least comparatively better documented than some of the other open source SDK projects I've seen that have sadly come and gone. Which is a shame, as I would have liked seeing some competition in this field. Whilst on the topic of documentation, I still prefer writing it in LibreOffice, largely as it provides sufficient formatting options to make it look like Sony's official documents, so one can pretend to be a wannabe licensed developer without having to download the actual SDK. It also allows me to export the document as a PDF for easier viewing without the layouts getting destroyed in the conversion process, from what I can tell so far at least. The only downside with documenting things this way, or at the very least I would imagine so, is that changes cannot be merged by version control systems. But I haven't run into this problem yet, as no one seems to have dared try to help with documentation so far, for which I can't blame them, as there's just so fucking much to cover in this project, and I can say from personal experience that it gets pretty tiresome to write documentation for this project, to be honest. PSn00bSDK has definitely come a long way since I made the video about it last year. Shortly after that video was out, I started pushing some pretty significant changes that adds a bunch of BIOS function calls related to PSEXE execution and reading standard in, along with numerous bug fixes and corrections. In case you didn't know, the PS1 does support reading standard in at the BIOS level, and this may work with the add-SIO driver in the serial IO library of SciQ or the Programmer's Tool SDK, but I haven't tested that myself. Standard in does not work with Kiteless TTY over parallel port feature, however, but it'll work on a custom cartridge firmware that I'm going to look into once all this PSn00bSDK stuff is out of the way. Among the other notable updates is an improved vsync function, adding a timeout which attempts to re-enable inputs if it gets stuck from not detecting vertical retrace interrupts for a while, whereas my original implementation would get stuck indefinitely. This helps prevent software lockups caused by some BIOS functions, namely the BIOS controller functions, which tend to mess with interrupt acknowledge settings on the PS1's kernel. The update also includes a significantly improved interrupt service subsystem for handling both hardware and DMA interrupts via easy-to-use callback hooks, replacing the crude and often unstable event handlers that don't always work on HLE BIOS implementations. The interrupt service subsystem is exposed for the programmer to use and are documented extensively if they wish to handle hardware interrupts directly as they so desire. Another notable update was the addition of the serial I/O library, with nearly complete support of the hardware on first introduction. And it even has its own implementation of add-SIO for redirecting standard in and standard out to the serial interface. This addition was integral for porting my light load loader over to PSn00bSDK with practically zero functionality lost, demonstrating PSn00bSDK's familiar syntax, allowing to port over existing projects with little modification. Not to mention the PSn00bSDK compiled version of Lightload is marginally smaller than the version built with the official SDK, showcasing how comparatively lightweight PSn00bSDK can get. About a month later, I managed to get C++ compiler features to work thanks to Israel Jax, I hope I'm pronouncing that properly, who led me to his little N64 SDK project when we discussed about how to get C++ compiler features to work in my SDK, giving me pointers for implementing the operators needed to get said compiler features to work. This only covers C++, however, not the standard C++ runtime library that you're most probably thinking of which I have no plans to implement anytime soon, largely as it may introduce a considerable amount of bloat if the complete runtime is implemented. Oh, and if you're trying to compile some C++ source and you get this linker error about vtables, try specifying fno-rtti to the G++ command line. I didn't notice this until recently when I was writing a new example program demonstrating C++ classes to actually test C++ compiler features properly. And I should also mention that the official SDK didn't have a standard C++ runtime library either, only things to support C++ features. Between July and October, I've mostly been pushing small corrections, bug fixes, improvements to the serial I/O library, and a bunch of new features added, mostly BIOS function calls and the immensely useful debug font API. I've also improved some of the original examples included in the SDK as well, and thrown in a couple of new examples, often to showcase newly implemented features or useful tricks. Such example programs include a first-person camera example with analog controller input, parent and child PSEXE switching, billboarding sprites, a render-to-texture example, one example that demonstrates the use of standard in for interactive text consoles, another example that demonstrates implementing a text console in a game loop, and recently, a modified version of the first-person camera example that runs in high resolution with anamorphic widescreen. If you want to look up every single change the SDK has received, you can always look up PSn00bSDK's changelog in the GitHub repository, unless you're somehow too dumb to click on the changelog file to see its contents. In November, I've managed to implement what is perhaps the most significant addition to the SDK, and that was the very much needed CD-ROM library. This library doesn't just work alongside the BIOS CD-ROM subsystem like a noob sauce library would. It actually interfaces a CD-ROM controller directly, which in my early attempts was an absolute bitch to figure out during PSn00bSDK's infancy, to the point that I found it to be infeasible, largely as the CD-ROM controller is highly interrupt driven for things like command acknowledge and data responses, but at the time, I haven't figured out how to handle hardware interrupts properly. That much improved interrupt service subsystem certainly helped a lot when writing the CD-ROM library for this SDK, that interfacing the CD-ROM controller became an absolute breeze once interrupts became extremely trivial to handle. Slowly but surely, I went from doing basic CD-ROM stuff like querying the table of contents all the way to parsing ISO 9660 file systems, reading files, and XA audio playback in a matter of weeks.
Got it working, but playback is crap because disk is crap or burned by a crap burner.
Data streaming for things like full motion video should be entirely possible in PSn00bSDK, despite lacking functions for handling such things out of the box. The CD-ROM library provides enough callback hooks for implementing a data streaming routine that uses a ring buffer, and I've actually seen others managing to get simple uncompressed FMVs to work in my SDK, but I sadly don't remember who did it first. MDEC compressed FMVs are not yet possible, however, as I still haven't figured out the MDEC yet, especially at the encoding and decoding side of it. It is by far the most complicated part of the PS1 I find personally. Everything else, including the SPU, much simpler in comparison. PSn00bSDK's CD-ROM library also improves upon the official CD-ROM libraries, as it does not have a 30 file per directory limit thanks to using dynamically allocated directory record buffers, and can deal with span directory records. However, the BIOS still has a 30 file per directory limit, at least for the root directory, so it's still recommended to conform to that limitation, as otherwise the console will not be able to boot your disk properly. The CD-ROM library also adds functions for querying directory records of the CD, integral for implementing things like file browsers in homebrew utilities and games that support loading user content. Rock Ridge or Joliet extensions for parsing things like long file names are not yet supported, though I do have plans to implement it as its own library at some point, provided the specifications are documented somewhere. A few months later, well into the Made in China flu, I was able to implement another noteworthy addition to the CD-ROM library in the form of the CD load session function. And as the name suggests, this function will actually load the ISO 9660 file system in a specified CD session, allowing to read files from an appended multi-session CDR. It achieves this by using the officially undocumented set session command, which seeks the optical pickup to the start of the specified CD session if one exists on the disk. This is much more reliable and easier to use than manually entering the absolute logical block address of a new session, which early attempts at supporting multi-session disks on the PS1 that I've seen use. Though seeking to a new session is not exactly that simple, as the function would then scan for an ISO file system descriptor after seeking to the new session, so it can determine the exact beginning of the new session as a logical block address. The only downside with CD load session is that it cannot select the newest session of a CDR automatically, largely as the CD-ROM controller has no such command for querying CD sessions on a disk, so a session number must be specified manually to access the new files. But at least only 1 or 2 digits need to be specified instead of a long string of numbers. One could try seeking to each session on the disk until the function fails, but this is painfully slow, especially as error recovery from a non-existing session takes a long while to complete. And apart from a bunch of improvements done to the makefiles, that's pretty much all there is to say about PSn00bSDK as of the making of this video. However, there's another thing that I managed to cobble together during this year that will surely complement the PSn00bSDK package. Ladies and asshole men, I present to you n00bROM, my very own spin of a Kytla style cheat cartridge firmware, only more developer oriented as it lacks things like a cheat system, which is kinda ironic given this is meant to run on cheat devices. n00bROM started life as a low-level programming test all the way back in the latter half of 2018 and was written entirely in MIPS assembly, but I didn't really push on with the project until the year of the Made in China flu, where it finally got off the ground and became what it is now. The idea behind n00bROM came about when I needed a cheat firmware that is more geared towards homebrew development and one that I can modify with ease. I also needed one that can also perform a swap trick technique that stops the motor during the swapping procedure to get around unmodified Japanese consoles when testing, as the Japanese consoles do not support no cache unlock. If the name wasn't obvious enough, n00bROM runs on a cheat cartridge, whether it be an Explorer, Pro Action Replay, or GameShark cartridge. Unlike other popular cheat firmwares such as Kytla, n00bROM is more oriented towards homebrew development than players, as it lacks any cheat options, which I won't add such a thing as I don't really see the point of having that in n00bROM. Being more developer oriented, it supports PSEXE or binary file download from either Serial or Explorer parallel port interface, with TTY redirection to either interface supporting both standard in and standard out channels, and PC drive file access supporting file create and write operations, which are actually not supported on Kytla, which was pretty annoying. At the moment, PC drive only works on Explorers, as I've yet to get around revising MCOMs and my SIOFS protocol at some point. To keep the size of n00bROM as small as possible, It is written entirely in MIPS assembly, which also allowed for greater control over how program code and data is managed between the ROM and RAM portions of n00bROM to keep its RAM footprint as small as possible. Originally, n00bROM ran entirely from ROM, but this became problematic with timing sensitive stuff such as serial downloads, as running code from ROM is considerably slower than running code from RAM. n00bROM's interface is quite simple and utilitarian apart from the real-time plasma background that runs at 60 FPS, but I think it suits it and it does the job. Pressing start from the main screen will attempt CD-ROM booting, with either swap trick or no cache unlock if enabled in the settings. Pressing select will bring up the ROM menu, where various options of n00bROM can be changed and also shows the cartridge type it detects and the brand and model of EEPROM it has, along with an option to flash the cartridge from within n00bROM so it can be updated or replaced easily, preferably after discovering how shit n00bROM really is. Under normal operation, n00bROM will listen out both serial and explorer interfaces while in the home screen for any upload operations being issued to the console. The latter only works if the cartridge type is set to explorer in the ROM menu. n00bROM uses its own protocol for the parallel port communications and comes with its own comms utility called XP-Comms, which works on both Windows and Linux. The latter would actually work with PCIe parallel port cards and possibly USB adapters too, as long as it shows up as a PAR port device. XP-Comms also provides the host for n00bROM's PC drive, providing a TTY text console, and supports uploading from ELF files without having to convert it into a PSexe first. n00bROM was also going to support CommsLink, which would have been most preferred as it allows for full 8-bit communications in both directions, but I was never successful at making a parallel port adapter for it, and I can't be bothered to support CommsLink USB as its author can't be bothered to release source code of the Atmega firmware nor USB driver. Besides, PS1 homebrew programming ain't complete if parallel ports aren't involved. Parallel ports are awesome. Anyway, n00bROM basically works pretty much like Kitela in this mode of operation, complete with TTY redirection to either serial or the Explorer's parallel port interface. I should mention that all upload operations are backed with CRC32 verification. The redirection will also work in games that still output debug messages through standard out, such as Legend of Legaia here, as TTY redirection is implemented by replacing the TTY device in the BIOS, which would normally point to some dummy function as otherwise. The only thing that n00bROM is lacking in this area is an automatic reset when uploading another PSexe to the console, like in Kitela. In the ROM menu, there are several options that n00bROM has to offer from here. Video standard specifies which video standard n00bROM will set the video mode to, but this option does not patch games to run in a specified standard. Auto detect is accomplished by simply checking part of the SCE string in the BIOS to determine the console's region easily. CD-ROM boot mode specifies which method to use when booting a disk. Normal just boots the disk normally as it would when booting games on the PS1. Unlock issues the no cache unlock command sequence that basically makes the CD-ROM controller read regular CDRs and thus booting it without requiring a mod chip. This option only works in US and EU region consoles, which is a bit strange and annoying personally as all the consoles I can find locally are Japanese. And finally, Easy Swap, which is a very easy to use swap trick sequence without the risk of damaging either disk or console, as the disk is stopped automatically during the swap procedure. But unlike previous swap trick implementations seen in modified Kitela firmwares and those PS Exchange boot disks, n00bROM swap trick implementation allows CD audio tracks to play properly, believe it or not. This is accomplished by using a set session command, which can be used like read talk apparently. But unlike read talk, which also rechecks the disk's wobble groove, set session does not do this, allowing the table of contents to be reread and thus allowing games that use CD audio to actually work properly in n00bROM's swap trick implementation. I'm not even joking. Have a listen to Vigilante 8 booting from the Easy Swap method. Or how about Invasion from Beyond, partly to admire its 60 FPS gameplay? Whilst n00bROM could be used as what is effectively a chipless mod chip solution, these features are mainly intended for making PS1 homebrew more accessible somewhat, especially those who don't know how to use a soldering iron to mod their console, or have an asshole friend who'd rip them out destructively as soon as they know of it. It is entirely up to the user if they wish to use it for that very purpose, or to boot backups, copies, bootlegs, whatever you want to call it. I ain't claiming responsibility for that kind of shit because I'm an irresponsible adult. It's pretty much the same argument with flash carts, really. Moving on, TTY interface specifies which interface n00bROM's TTY device hook will use, the options of which are self-explanatory, though the Explorer option will only work on an Explorer cartridge, naturally. PCderv installs a special PCderv device to the BIOS that can be used to read or write files on the PC host. This feature is present on both Kaitla and official development units such as the DTLH-2000, and is useful for uploading stuff that gets updated frequently. PCderv by break opcodes with specific argument values are not yet supported in n00bROM. Exception specifies if an unhandled exception handler should be hooked to the kernel, so that a kill screen with a register dump would appear if a program causes an unhandled exception. Originally, this is implemented by hooking to the exception vector directly, though it tends to cause compatibility issues. But that's since been replaced by a much better hook via the function table entry for BIOS function system error unresolved exception, which does not cause any compatibility issues to any games as far as I'm aware. So this option may get removed or replaced in the future as it's kinda redundant. Enabling exception also allows poll host break opcodes to be ignored, which may allow development prototypes that use such opcodes to work properly on a retail console. Cartridge type specifies the type of cartridge n00bROM is installed on, which is still a manual setting here as cartridge detection is not always reliable. Setting this option to either PowerGS or Explorer will make n00bROM check the switch for each cartridge type, and for the Explorer option, enables Explorer parallel port downloads. Make sure you set the cartridge type correctly as choosing the wrong type other than generic will brick n00bROM. Essentially, it'll get stuck letting the BIOS boot normally or perform a quick boot. Off switch action specifies what action n00bROM will take if the switch on a cheat cartridge is set to the off position. BIOS simply prevents n00bROM from taking over and lets the BIOS run its shell, while quick boot jumps straight to n00bROM's boot sequence with either no cache unlock or easy swap depending on the boot mode setting. Speaking of, no cache unlock and easy swap are also issued after a PSEXE has been uploaded to the console. The background option specifies the background graphic to display in n00bROM screens. Plasma shows that high-speed real-time plasma animation, whereas SMPTE shows color bars so you can pretend that you have one of the official development units and feel like a total noob. Home screen sets what to display when starting up n00bROM. Banner basically tells you not to scalp n00bROM like a low-life piece of shit. Minimal just displays a small banner that also shows some of n00bROM's current settings. BG only just displays the background only so you can appreciate the plasma or color bars more. The flash mode option is n00bROM's built-in flash utility for easily updating n00bROM, which was obviously extremely useful when developing new things into it. It can download and flash a ROM image of up to 128 kilobytes in size from either serial or the Explorer parallel port interface. n00bROM also improves upon Kaitla by supporting many more EPROMs and even identifies the make and model of your cartridge's EPROM as mentioned earlier. If n00bROM finds an EPROM it does not recognize, it will refuse to save settings or enter flash mode. You can get around this somewhat by hard coding settings you want in n00bROM's assembler source, or add an entry of the unknown EEPROM in the tables file so n00bROM becomes compatible with a chip. One of the advantages of open source software. And I guess that's all there really is to say about PSn00bSDK and n00bROM so far. And I'm glad this video turned out adequately short judging by the length of this narration, so I can get this video out before this shithole of a year has come to a close. So anyway, I'll leave the rest to that annoying dickhead in front of the horribly outdated standard definition camera. So I guess that about does that for both PSn00bSDK and n00bROM. The only thing left to do with the PSn00bSDK, or at least I think so, apart from the SPU library, is the MDEC really. I still haven't figured it out, in large part because I'm not really very familiar with JPEG style encoding and decoding, which MDEC seems to be derived of, but it has differences. It's not exactly the same. The best I've got out of it is a garbled mess of green pixels, and I'm working with like some really old existing code to do that. Nicholas Noble's old MDEC routines that he wrote back in the year 2005 or so. So that old. And I'm not even sure if they're working properly when built with newer versions of GCC. So I'm a bit in the dark when it comes to MDEC at the moment. I'm not sure if it's because I did not set the quant tables to the MDEC properly, or the MDEC data had to be ordered in a specific manner after Huffman decompression for it to decode properly. I think it's like 64 16-bit words per macro block, that include for the luminance and then the chroma blocks. I'm not sure. I'm not sure. I'll have to do more research on that. So I'm still not inclined to make like a tutorial video on how to set up PSn00bSDK. I won't mind if it makes me sound like a dick, but to be honest, it's not really meant for beginners to play with yet. Because, well, it's a bit experimental in my mind, even though you can already do quite a bit on it already. Hell, I even saw like one make like a full-blown 3D engine on PSn00bSDK with rendering actual terrain and has fog and LOD, or maybe I'm confusing the LOD stuff with another project that's it was made with the official SDK. I don't. But basically, you can already do quite a lot with PSn00bSDK, especially as it supports the GPU and GT rather extensively. Way better than any other open source SDK I've seen that has come and gone, sadly. Which is a shame, because I really would have liked seeing other projects in this field. And sadly, it seems PSn00bSDK is the only one that's still in official active development, I should say. However, I do plan to look into making PSn00bSDK, and I'm gonna look into like distributing it in binary form already, either a deb or a pacman package that you can either install in your Debian Linux system, or Debian based Linux system, or in your MSys2 shell if you're using Windows. And it won't just have like the whole PSn00bSDK stuff, like the GCC compiler required, the libraries that are already compiled, the example programs, the documentation, but also other tools that are quite handy for homebrew development, like MKPSX ISO, MCOMs, and also my TimEdit tool, already bundled in the package. So it's basically an all-in-one bundle to get you going for PS1 stuff. That one I much prefer doing. Yeah, because I don't really see the point of video tutorials. I never follow video tutorials. I always go for text tutorials. They're easier to load. They're easier to seek around if you need to like revise a step. I don't know, but generally for absolute beginners who are new to C, C++, I recommend going with SciQ, because it seems to be the easiest to work with if you don't mind like downloading like the SDK from PSXDev website. Sony won't really go after you really. Well, it hasn't for me, and I stuck like my real name on my GitHub and nothing has happened. Speaking of, I'm gonna stick my real name on more things in the future because I take pride on that. I'm not a coward. Yeah, eventually I'm probably gonna end up taking a hiatus on like PS1 stuff for a while, or at least for the most part, because I'm already like I've been working on PSn00bSDK since like 2018 for fuck's sake, and I've been programming for the PS1 in like so many years already, to the point that I get a feeling, some kind of feeling when I look at that Marilyn game again after digging it out from all these years. I can't find a word to describe what that feeling is that I got, but it's something about like it reminds me how far I've come really. So I plan to remake that that style of game, but on PSn00bSDK at some point. Won't have the Marilyn character anymore. Probably a sample demo that you can use to start off, start a project off of. That'll be included in PSn00bSDK in the future. I think that's all PSn00bSDK stuff out of the way. Yeah, I wanna focus on other things. That's why I've been delving into like DOS development stuff with like some random magical girl thing. Just to diversify really. It's I need take a breath of fresh air, to be honest. I'm so. I'm still gonna do some work on PSn00bSDK and n00bROM still. Mostly small work like documentation and fixing up, improving instructions and fixing up some things here and there. And then maybe try to get the SPU stuff fully elaborated. Okay, so as for n00bROM, I was originally gonna like implement a feature where you could like store a PSEXE into the cartridge's EEPROM, so that you could start it from the cartridge, so to give n00bROM a bit more utility. But that was actually one of the original ideas I planned to implement for it, but never been able to get around to that. I'm not sure if I should make it so that you just upload like one PSEXE to the cartridge, or have some kind of file system so you have like multiple PSEXEs compressed in LZ77 in one cartridge. I'll have to look into that at some point. Also, lately I've been trying out like a little experimental trick with n00bROM. Mainly some kind of intercept mechanism for GPU-GP1 writes to force games to run in an interlaced mode. At the moment it just causes the game to lock up and the video display goes away. I'm not entirely sure what's the deal with that yet. The intercept doesn't cause anything else to crash. Like, it will only intercept if it detects a certain type of write with a certain instruction and a certain register value. It will only intercept. If it's not, it will just let the system carry through. So I have to look into that. Force interlace would be handy for getting PS1 games to display properly on TVs that don't like non-interlaced video, like my HD CRT, or to prevent scalers from like blanking out from video mode changes, especially when you're playing like Silent Hill. And there's also another thing I'm considering implementing in n00bROM at some point, and that is like a dex drive mode, where you could essentially use the PS1 like as a dual slot dex drive. So you could like to use it to back up like your memory card saves or image your memory cards with ease, using familiar dex drive compatible tools. So I'm gonna look into that too in the future. But I think for most part in the first months of 2021, I'm gonna be binging like DOS and DOS stuff for a while. And I also have this little thing in the works. If you've been following my live streams lately, you should have known it by now, and that is This thing is the Lameputer 8064. It's based around the 6 MHz Zilo Z80. I was originally gonna base it around an 8 MHz Z80 instead, but the 8 MHz chip I bought that I thought was the processor turned out to be a PIO chip. It's very stupid of me because it really said there it's an IO chip, not a processor. But no problem, I can use the chip with this version of the Lameputer still. It's gonna sit right here. It's gonna serve as a parallel comms link interface of some sort with fancy things like hardware interrupts and handshaking, and which would save me from having to use like a crap load of logic chips, and that implementation may have not worked as well as using like a Z80 PIO. And also the Z80 PIO can also be used as an input for a keyboard interface, keyboard matrix once I get around to making a keyboard for this thing, using its B channel as an input. The A channel can do bidirectional, but it uses the B channel's handshake signals, so the B channel will be limited to either outputs or inputs, really. So yeah, this system will be spec'd with initially 8 kilobytes of SRAM, but it can be upgraded to 32K, and also either on 128K or 256K page mode EEPROM for both the program, for both the bootstrap, monitor, and software, but also as primary storage. These two chips here are just dummy for illustrated purposes. As you can see, I've had the data bus wired up. The address bus is not finished yet, and I haven't put on the glue 74 series logic to handle the memory mapping yet. The ROM will be mapped to the first 8K of the Z80, with the upper 4 kilobytes being page remappable to other pages in EEPROM, so that the whole 128 or 256K of ROM can be accessed without eating too much of the Z80's 64K memory space, and the rest will be RAM. But the logic would be made in such a way that you could override the onboard memory chips and basically mask memory accesses. So for like RAM expansion or other memory map devices that I'm gonna stick to it in the future. Originally I was gonna design the Lameputer 8064 as some kind of like an Altar 8800, where it has like a huge row of like toggle switches and a huge row of LEDs as well. But I decided to just cut down on it and make it just what is effectively a headless SBC. You'll be initially you'll have to talk to it through parallel port interface, taking advantage of its bidirectional capabilities for now, until I get the software done. Once I get the software down pat, mainly a CPM style operating system that's not necessarily compatible with CPM software, and once I get that down, I'm gonna look into adding like some kind of display on it, either one of those character LCD displays that are quite literally calculator displays, or like a TMS 9918. I won't mind dealing with like the old style DIP DRAM on it. It would look cooler for the computer, because rows of DIP DRAM always looks cool. And I have no problem with negative 12 volts, because the power supply that I'm going to build for it, using this like transformer here, will supply negative 12 volts for such things. I don't know, we'll just see. For now I have to write the software for it. Speaking of software, one of the design goals I have planned for the Lameputer is effectively going to be like pretty much a shitpost computer that makes fun of like modern day computing, makes fun of modern day security, and exclaiming that security is only meant for like Nancy boys and pedophiles, though the latter are usually too dumb to take advantage of those things. And also how modern computers are starting to lose the personal in PC, because companies, especially Microsoft, are like, they want to like control the computer. You don't control the computer anymore, so it's not a personal computer anymore. It's just a leased computer, which seems to be a way where tech is heading now, which sucks. That's why modern day tech is stupid now. Eventually I won't be surprised if things become like a bunch of dummy a bunch of dummy terminals that run like some kind of fancy interface, just enough to run like just enough to get onto Facebook and other social media platforms. That seems to be where tech is heading, annoyingly enough. So in that case, the Lameputer can probably be considered a true personal computer. Well, quite literally so, because I've actually built it. The design of it is my personal preference. Everything about how it works is my personal choice. So it's really a truly personal computer system, not these modern glorified Facebook terminals that are shifting to ARM. I want leg architecture. That's much better. Leg architecture. So credit to High Treason for coming up with that. Anyway, so yeah, Lameputer. I'll certainly do a video about it and its design. Oh yeah, I think I haven't mentioned that one of the other things I want to do with like the Lameputer is it's gonna be like to accompany that its security mockery thing, is that it's gonna be like an information-free technology system. You know how there's information technology? What if there's an information-free technology? I fancy the idea of making the computer in such a way that the string functions would like check strings constantly, to the point that in such a way that if it detects anything that looks remotely like a name, it would just automatically kill the computer, like wipe the memory and then restart the system abruptly. I'm probably not gonna implement that because it's gonna be quite difficult. It's gonna require like a huge table or lookup of some sort. I don't know. Maybe I'm gonna focus more on like having a ridiculous license disagreement that's gonna give like a modern day IT representative a confused look or something like that. I actually look forward to once the Lameputer is like fully working and demonstrating it, and then an IT representative of some other school would like talk to me and then ask about the computer, and I say it's an information-free technology computer, and then he's like confused look on his face, or he just laughs or the confused look and then walks away. I would feel very accomplished if he does that. Okay, I guess that's really it for this post ramble about. Oh yeah, one more thing. This video is I actually edited this in the most recent version of Kdenlive that was on their website in app image form. I got the most recent version they have in app image, and guess what? It's broken, or at least the previews are broken as hell. As it flickers to hell and back. But if I like put it on like my second monitor, it displays fine. But it's still quite annoying because I want to have like my main preview on my second monitor, and then the smaller preview should be for like scrubbing around clips. And it also has that annoying bug. It has that annoying bug where if you have a clip that has no audio track, you cannot seek. There's no timeline for that clip. So you cannot simply click around the clip to seek around when there's no audio track. I'm not even joking. You cannot seek. It's really stupid. That wasn't the problem in like older versions of Kdenlive. I guess that's why I found when I updated, like when my workstation used to run Archvile Linux, and then I discovered I could not seek clips. It must be because of that. You cannot see clips if there's no audio track on the file on your video clips, which is very annoying because I tend to do captures that don't have an audio track to save on space. So now I have to like put a bunch of put on a bunch of like dummy audio tracks. I don't know. It's still quite annoying. Made this video rather irritating to work with because I had to like fiddle with like the playback controls instead of like clicking to a point in the timeline for that clip. What's up with software nowadays getting worse? Is this the future of technology? Buggy, barely functioning software? I guess it's because things expect me to run like the latest hardwares, but fuck you. I'm still working on my Z600. This Z600 should last another decade. Stupid. What do you want? I hate it when things expect you to run like the latest hardwares. I mean, I'm even gonna go as far as like I'm contemplating doing things like making my software not work on like Windows 10, for example, just to be a prick. I just don't like where tech's heading. I've never liked it. I'm already seeing how annoying this is. And then I keep complaining about software being buggy and problematic while everyone else looks at me funny, wondering why I'm screaming and squealing, why things aren't working right. Because the software has been bastardized in newer versions. And then no one will notice. No one but me will notice this trend in technology. The Lameputer is probably gonna like try to address that, even though people are just gonna look at me funny, showing off that computer in like stage presentations in the future. If I ever get an opportunity to be put on stage or something, which I highly doubt. Not a very nice person anyway. So yeah, I guess that's pretty much all there is left to say. To be honest. Pardon if this video turned out to be a bit of a rush job, but I had to finish this up as soon as possible before the year comes, this shithole of a year that is the Made in China flu year 2020 comes to a close. And I don't know, I don't know, I think I haven't rambled about future videos yet, so yeah, I have to rush it. I should have made this video sooner, to be honest, but a bunch of things got in the way, delayed me, so I just wasn't feeling it for some reason. So future videos, I'm most probably gonna do videos with like my old computers, especially my 386DX, because I've had that for a while, for a long while, since like my early years of like dicking around with old computers. And well, that was my oldest computer for a while until I got my uncle's 386SX16, which I did a live stream with a while back. So yeah, maybe I'll also look on that 386SX in the future as well. Music stuff, I also have to get around to that too. I have to like fix up the themes before I release them. I'm gonna see about putting them on SoundCloud first, and then making a simple little music video of sorts for it. Speaking of, I haven't been into my haven't logged into my SoundCloud in a very long time. It would suck if I could no longer log into it anymore, but I should be able to log into it. So yeah. I'm pretty much out of breath. This post rambling has taken many takes already. I'm already quite exhausted. So yeah, anyway, I guess that's it. Thanks for watching. This is LameGuy64 and signing out, and see you in the year 2021. What should be my New Year's resolution for the next year? Well, I wanted to go back to 1600 by 1200 just like my old CRT days, and also my Samsung monitors are rotted out now. But we all know nobody makes square aspect ratio screens anymore because everyone wants a stupid wide screens because stupid. So 1920 by 1200 will have to suffice, but I guess I'll have to order one of those abroad because no one here sells 1920 by 1200 here. Only 1920 by 1080, ultra wide, or fuck off because stupid.